How can properties of operations be used to add linear expressions? Think about this question during the lesson. Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? Here's a hint. Each bill can be represented with an expression. Let's use bar diagrams to represent the situation. This diagram represents the data for the ACE Health Club. It has an initial fee of $80 and a monthly fee of $50. This diagram represents the data for Rudy's rock climbing. It has an initial fee of $65 and a monthly fee of $40. Now write an expression for the cost of each club.
All right, so if we have to think about two things, we have to think about the constant and we have to think about the term with the variable or the coefficient. So if we look at the health club, so you are paying $80 as a startup for the health club. Okay, you're only going to pay that $80 once. So that means that the $80 is going to be our constant. Just like down here for the rock climbing, the $65 is going to be our constant. Okay, which means that the other one has to be our coefficient. Okay, because we're only in two-step equations here. So we have a constant and we have a coefficient. So we know that for the health club, $50 is our coefficient. And down here we know that $40 is our coefficient. Okay, so just that alone, thinking about those two things, we can try to start to set up an equation. Okay, we know that for the health club and the rock climbing, we're going to have to pay that startup fee as well as the monthly fee. Okay, if we have to pay both, that means we're going to have to add those two together. We're going to have to pay them as one whole deposit. Okay, so adding them makes this 80 plus 50, and then the coefficient means we have to put a letter with it. Okay, it says that we have to use M for months. So 80 plus 50 M. And down here it's 65 plus 40 M. So the first thing we need to think about is your constant and your coefficient, and then how to put them together in an equation. So let's watch the rest of the video.
The ACE Health Club diagram can be expressed as 80 plus 50 times M. And the Rudy's rock climbing diagram can be expressed as 65 plus 40 times M. How can you find the total fitness cost of the health club and the rock climbing gym?
Okay, again, we're paying for the health club and the gym. Just like when we wrote the equations, we had to pay the startup fee and the monthly fee. So and is telling us that we're going to add those two things together. So we're going to add the equation for the health club, and we're going to add it to this one. Just adding them together, we're just putting a plus sign between the two. We're adding whatever that is, to whatever that is. Okay? Implying that we need to know what this is first, 50M, and we have to know what this is first. We're adding this total to this total. Okay, as you'll see in the video, it explains the same thing.
You can add the expressions to find the combined cost. You can use the commutative and associative properties to group the constant and variable factors. Now, combine like terms. The expression 145 plus 90 times M can be used to determine the total cost for the health club and rock climbing gym after M months. Now you know how to add two algebraic expressions.
All right, so another way to do this before I start the new activity. Oh, wait, will it let me? I don't know if it'll let me. I'm going to back up a little bit so that I have writing space. All right, another way to think about this is, they said use the associative property and the commutative property. So they took this 50M and they moved it down there to get the like terms together, and they used this 65 and they moved it down there. Okay, they did a little switcheroo. If you're not confident in being able to do that on your own, remember that I said if there's nothing there in front of a parentheses, there is a 1. Okay, so you could also distribute a positive 1 through those two expressions to get to the same place that we're going. Okay, so if we distributed a 1, it's 1 times 80, which is 80, and it's 1 times 50m, which is 50m plus. Then it's 1 times 65, which is 65, and it's 1 times 40m, which is 40m. Okay, that's where they get to. This here is pretty much the same as this here. Okay, we can combine like terms, which is what they're doing here. So our 80 and our 65 and our 50 and our 40, we have 80 plus 65 plus 50m plus 40m. Okay, 80 and 65, 145, 50 plus 40, 90m. Okay, so if you're not confident in using the properties, just distribute a positive 1 and then combine like terms. Okay, if, however, let's think about this. If Rudy's rock climbing, okay, if they didn't tell you that it was $40 per month, okay, it's not month anymore. If it was $40 per year, why? Years. Okay, we couldn't just write the equation. We could add the equation still, but we wouldn't get like terms. We wouldn't get, I wish it would let me change colors, but it's fighting the system. There we go. We wouldn't get months and months. This would be Y, in which case we couldn't combine the like terms. So what could we do? Well, we could just find out what, if it's 40 for a year, how much per month. So we would do 40 divided by 12, and that would give us our M total. Okay, so it wouldn't completely put a wrench in the plans. We could still figure it out. We would just have to do another step first. So let's go on and see what's next. Got to play through the video first.
To add 2 algebraic expressions.
Okay, this just shows you what we're doing when we know the number of months. Okay, and the problem before, we didn't know how many months they were going to be signed up for, so that's why we used M. We use variables for things we don't know. Well, here it's telling us that if M is 1, if they only do it for 1 month, they're paying $235. If they're part of those gyms for 3 months, they're paying $415. If they're part of those gyms for 4 months, it's $505. If they're part of the gym for 6 months, it's $685. That's where that substitution for 4.1 comes into play. Once we know the number of months, we can solve the equation. This takes us back there, so let's move on to here. All right, so here's another problem. Sophia and Ollie each deposit $120 to open a joint account. They each make monthly deposits as shown. What expression represents the amount of money after M months? So let's get, I can use my writing tool here. Okay, so Sophia deposits and Ollie deposits. Okay, so Sophia deposits. Remember the first thing I said is find out the constant and the coefficient for both. Con and coef. Okay, the constant for Sophia, the thing that only happens once, is this $120. They just put that in there. Okay, so the constant is 120, and it's the constant for Ollie as well. Okay, Sophia's deposits, she puts in $150 per month. If you have to say something per something, that gives you the hint that that's going to be your coefficient. So the coefficient for Sophia is 150. The coefficient for Ollie is 135. He deposits $135 per month. So we can take these numbers here and put them in on these equations over here. So our constant was 120 and our coefficient was 150, 120, 150. Okay, here's where they use the associative and the commutative property to group the like terms. So we have 120 and 120. Those are both our constants. I know they go there because there's no m here. That tells me that those are the spots for the constants, which means the other two spots are for the coefficient. So we have 150 and, oh, it wasn't 150. This is supposed to be 135. 135. Hopefully you caught that and didn't fill that in on your page. Otherwise, hopefully you're using pencil and you can erase it. Okay, so now we can group those like terms. 120 plus 120 is 240. And the coefficients, 150 plus 135 is 185. Okay, so there's something wrong here. They missed something. Okay, what did they miss? Giving a little bit of hang time so that you can think about what they missed. They missed the coefficient here. Then it should be m and then a period. That's going to be the equation for figuring out how much they would have in the account after so many months. So Convince Me says, explain why the initial deposits and monthly deposits are not combined into one term. Okay, well, why is that? Well, because these, the 120s, are the constants. They are like terms with each other, and the other two are coefficients. The deposits are coefficients. They happen repeatedly, which means they're m's. And we can't combine constants and coefficients. We just can't. Okay? Let me erase here. One. Ooh. I gotta use this fancy one. Oh. There we go. There we go. Will it just clear off if I switch, you think? Let's try it. Example 2. All right, so here's another example. Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. To start this one, you have to know what a profit is. Okay, when we're talking about profit, that's how much money they made after taking back what they spent initially. Okay, so if we think about the constants and the coefficients, okay, this lesson is all about adding two expressions. So I know there's going to be two constants, and I know there's going to be two coefficients. That's what we're learning. Okay, so the constant for muffins, we have muffins, and we have bagels. Okay, the constant for muffins, well, she spent $125 on the muffins. And bagels, one time she spent it $92.40 on bagels. Okay, now we have to think of our coefficient. So what is happening per muffin? Okay, well, the price per muffin. People are paying her back the money per muffin that they buy. So it is $2.40 per muffin. And it is, where's the bagels? $1.80 per bagel. Okay, we're starting to see something a little different here. We have an M and we have a B. Okay, that could lead us into some issues here coming up. It could make it more complicated. So, for the muffins, what is the expression for finding out her profit on the muffins? Well, for every, she makes $2.40 per muffin, and she is going to subtract the $125 she already spent on those muffins to figure out how much money she makes after all the muffins are gone. Okay, we could rewrite this if it makes more sense in your head that she was $125 in the hole, and then to it she's adding $2.40 per muffin. Okay, they're the same thing. Those are equivalent expressions. Okay, the 125 is negative and the 240 is positive, so it works the same. Okay, so for the bagels, we could do the same thing. It's 180 per bagel, and she's taking away what she spent on it initially. Or we could rewrite it the same way. Negative, she started out in the hole, and she's adding to that $1.80 for every bagel that she sells. Okay, so there's our two expressions. Write an expression to represent Cindy's profit for M bagels and B bagel, M muffins and B bagels. So we have an and here. So that means we're going to probably add those two things together. So if I can switch, oh, I almost had the green. Oh, I had the red. I don't know, I give up. Okay, so we have, I like the positive, so they're starting with the positive. So 240 M minus 125 plus 180 B minus 9240. Okay, so there's our expression that we wrote to find the cost of the bagels. Not sure if it's going to erase this when I move on or not. We'll find out. Nope. Oh, it didn't do it. There we go. Nope. So let's take an eraser here. Get that out of there. All right, so if you will look, here is the expression that we came up with just on the last page, right? 240M minus 125 plus 180B minus 9240. Okay, we got that. Now to add them, you'll see that the only like terms that are there are our constants here. So they moved this one, put it down here with the 9240, and then these are different coefficients. They are not like terms. One's an M, one's a B, so we cannot put them together. The only thing that we can combine are the constants, and they come out to be negative $217.40. To find out how much Cindy makes after she sells so many muffins and so many bagels, again, we don't know how many muffins and bagels, this is the equation that she would use to find out her profit. Okay, if we wanted to know how many muffins and bagels she had to sell to come out to be positive, we could put, I would probably start by putting a 10 in for both of these. 10 muffins, 10 bagels, because I know $2.40 times 10 is 24, and 1.80 is 18. Okay, I can do tens easily. Okay, so tens is easy. If that moves this decimal one spot, I'm making $24 and I'm making $18. And then I'm subtracting that 217. I know I'm still going to be in the hole. So 10 of each is not going to work. So what if I do 100 of each? That's 240 and 180. And I know that's more than what she spent initially. So that's how I know that she's going to come out positive. If she sells at least 100 of each, she will come out positive. Okay, so there's one more example here. If I can get my cursor back. Example 2, we go to example 3. Oh. Is it going to switch for me? Go. Add the expressions. All right, here's a straight figure it out question. There's no fancy story problem that we have to deal with. We're just doing it. Okay, so the first way that the video taught us to do it was to use the commutative and associative properties to group the like terms. So we're still finding what the like terms are. So we have 1/2 x, and we have a positive 1/4 x, and and we have a -3 and a +5. And we have a -2y minus 2 and another -2y. Okay, we've used the associative commutative properties to group the like terms. Now we can combine them. So 1/2 plus 1/4. 1/2 is otherwise known as 2/4. So we know that there are 3/4 x. -3 plus 5. 5 is the greater absolute value, so I know my answer is going to be positive, and 5 minus 3 is 2. Then I have -2y minus another 2y. So I'm already in the whole 2y. I'm giving away more 2y, so I know I'm going to have a -4y, or I'm going to add the opposite. So -2y plus -2y is -4y. Okay, I can't combine my x's or my constant or my y's because they're not like terms. I cannot do it. That's number 2. Oh, here we go here. Okay, well, before I erase it, you can see that 3/4 x minus 4y plus 2, they're all there just as we had them when we solved it. Our -4y and our +2 are just in a different order. Okay, again, there's no parentheses and stuff, so they can be in a different order as long as they have the same sign. So let's go to the third one. All right. Ooh, here's 4 that we can solve. Okay, find each sum. I'm not going to solve them all, but we're just going to practice putting them in the right order so that we could go to the farthest step. Okay, so again, we're still combining like terms. So we have a c, we have a constant, we have another constant, and we have a p. Okay, so our equation over here, there's only one c, so it's going to be 9.74c plus -5.48p. And then my 2 that go together. I have 250.5 minus 250.50 minus 185.7 equals -64.8. Okay, you're probably thinking, Mrs. Martin, that is not what the equation says. I know. Okay, but I know that my answer is going to, this has the greater absolute value, so I know my answer is going to be negative, and then you just subtract. That's what I did. Okay, I didn't have to go, oh, okay, so 250.5 negative plus 185.7. Okay, it's going to give me the same thing. I just know to do that in my head already, to use the sign of the bigger absolute value and then just subtract. Okay, so if we look at the second one, we have an x, and here's an x. This is a really skinny constant. We'll use triangles. There's a constant, there's a constant, there's a y, and there's a y. Okay, so we have 2/11 x minus 3/11 x. Okay, it's going to be negative because negative 3/11 has the greater absolute value. And then I'm going to subtract. 3 minus 2 is 1/11 x. Okay, if we do triangles next, I have -3 and 5.5. Well, my answer is going to be positive because 5.5 has the greatest absolute value and it's positive. And then 5.5 minus 3 is 2.5. Last one are my y's. I have -5y and +5y. Those are opposites. They are not going to be in the next equation because they're opposites. Okay, C, D, try those ones on your own. I'm pretty sure we get how to do it from now on, so I'm not going to do them to save time in the video. But hopefully You've copied all of this down in your book, and you've followed along with me in your book, and you have some notes to reference for when you're doing it on your own.